Hello and welcome, I'm Kamal Tkodra, Technical Marketing Engineer in the HPE Aruba Networking Switching Business Unit. In this 10.14.1000 update, we're going to be talking about PIM bidirectional, both dynamic and phantom RP. So let's get into it. For this PIM bidirectional update, the agenda is as follows. We'll have an overview. We'll cover some use cases, some basic configuration information, and then we'll go straight to a demo. So I've provided an overview, some multicast terminology, which you can look at your leisure, either pause the video or download the slide deck. These are all very useful when looking at PIM bidirectional. Now in AOS 10.14.1000, we now support dynamic and phantom RP. Now remember that the bidirectional RP is in both the control plane and the data plane of the shared star, G tree to build a multicast topology. With dynamic RP, we'll use the candidate BSR and candidate RP methodology that you should all be familiar with already when we have dynamic RP, and so this is the same methodology that's used in PIM bidirectional. For phantom RP, we have a static discovery and we select the RP based on the best mask match, and we'll go into that a bit later. So overall, this provides us with resilience and HA in a multicast environment when we're using PIM bidirectional. It also allows us to do load sharing, and a HA split bias is also possible. It's both suitable for campus and DC. It's an IPv4 multicast only support. There's no new CLI for the phantom or dynamic RP, and no feature pack is required for this enhancement. And the supported platforms are as shown below. So let's go over the PIM bidirectional journey. And 10.12 and below, we have multicast routing in CX for PIM dense, PIM sparse mode, and PIM source specific multicast. And in 10.13 we did introduce PIM bidirectional, which is just for underlay routing, and we only had a static RP, so no HA available, and details of which can be found in public on the YouTube Airheads broadcasting channel as shown below. Now in 10.14.1000, this update, we are now introducing both a dynamic RP, which allows HA and load sharing, as well as a phantom RP, which allows HA and some element of load splitting across 8 groups. So let's do a quick review of PIM bidirectional for a refresher, but please look at the 10.13 update for further details. So remember, PIM bidirectional in CX is only for IPv4, and we create bidirectional trees between sources and receivers without having source specific state. So there's no S, G entries are not maintained in this type of multicast tree. So source traffic is always sent to the RP and then towards the receivers. And remember that PIM bidirectional RP is both in the data and control plane, which is unlike PIM sparse mode. So what are the benefits here? So we're removing the shortest or the source path trees and the S, G entries. This means less resources and overheads are on the switches because we don't need to maintain these states. So we can build multicast networks that scale better than PIM sparse mode when we have a use case which is a many to many and highly distributed sources and receivers. Now let's go over phantom RP. So a phantom RP is an actual address that does not actually exist on the network, and hence the name Phantom. The Phantom RP is an address that belongs to an actual subnet and is only pointed to effectively in our setup. So the same IPv4 address is advertised with different mask lengths. So if we look over on the left diagram, we can see a 192.168.1.1/30 on one loopback and 192.168.1.1/29, and within those two loopbacks exists 192.168.1.2, but we don't configure that on any of the loopbacks, so that's what we're trying to get to here. Now, the longest match subnet advertised through the IGP is selected as the active RP. So in this instance, the 1.1/30 would be selected as the RP. The less specific matching address becomes a redundant RP, so this loopback here /29 becomes a redundant RP and only takes over if this device or loopback fails somehow. Now, the Phantom RP allows us to have HA RP in a PIM directional environment. We also can have a HA bias of up to 8 multicast groups too, and we can allocate specific multicast groups to this set, and maybe we can create another set and align multicast groups to that set. So that's what that's talking about. And then finally, just to be clear, that the CX PIM BIDIR can also use a BSR and candidate RP for HA and load sharing too, which we'll cover in configurations later. Let's now take a look at some use cases. So in this typical campus with an Edge DC, we have deployed a RP BSR scenario using PIM bidirectional. So typically the RP, HA and load sharing is critical to multicast production environments, and that's what we've done here. And dynamic RP, as shown here, is best suited for most environments. And here we see that sources and receivers are highly distributed across the enterprise. So we can see receivers on campus building 2. We also have sources and receivers in campus building 1, as well as sources and receivers in the on-premise DC. So this makes it really ideally suitable for PIM bidirectional. Example applications for PIM bidirectional, things like UPnP, simple source discovery protocol, multiplayer games with chat, trading channels and market data systems like Bloomberg terminals, and CCTV with high dense sources and receivers. So let's look at the small campus use case where we have effectively a collapsed core. Now we can use static Phantom RP in these small environments with smaller multicast groups because you have configuration that you can manage across the devices, as well as you won't need possibly as much load sharing. However, dynamic RP is still suitable for all environments and still can be used in the small campus use case too. Now let's look at some configuration details. We're going to now look at Phantom RP configuration. The first thing we'll do, we'll look at a design requirement. So we need to provide HA and split some multicast groups under non-failure conditions. So we've got a couple of multicast groups here, 239.220 and 239.3.2.0. So we want to split these in pairs, and so what we've done is we've taken 2 Phantom RPs for one for each group. So 192.168.1.225 is our Phantom RP for our first multicast group, And for our second multicast group, we've selected 192.168.1.241 for our second multicast group. Now we look at how we can address these. So let's look at the first group, and we can see that in the first group, 192.168.1.225 and 226 sit in a /30, those two host addresses in that range. Now if we look at a /29, that also includes 225 up to 230 inclusive, and this is why we've made the phantom RP .225 and we've allocated our loopback addresses as 226 with a longer and a slightly shorter mask, and so the preferred RP would be the /30 and failing over the /29. Similarly, we've done the same for the other multicast group, and if we look at the configurations, so on the left, our RP has a loopback of .226 as we've selected here, and then our backup RP is .242 with a /29 on that host as shown here in the table. Now our RPs are grouped with the specific multicast groups of interest. So .225 has a group selected as 239.2.2.0, so that group will always go to a /30 on this side, and under a failure would then go to the /29 on the other switch. And conversely, we have it the other way round for the other multicast group 239.3.2.0. we have a /30 here for loopback 172, and on the opposing switch we have a /29, and then we look at the RPs that we're pointing to 225 for 239.2.2.0 first multicast group, and 239.3.20 for the second multicast group. And we can see the .241 belongs to .242 here, and it being the longest match would be the preferred multicast RP, and under failure we would use the /29. So this gives you a really good overview of the configurations on the actual RPs. Now let's take a look at elsewhere in the network too. So just as an example, we can see the configurations on some of the access switches and aggregation. Again, we must have PIM bidirectional enabled on every hop, and really in terms of the RP under the PIM routing process, you must statically configure your RPs on each hop too. So here we are pointing to the two RPs that we identified earlier, .225 and .241, with the specific multicast groups, and this is shown on this aggregation switch here. And then similarly on the access L3 access switch here too, we have the same type of configuration, and it needs to be consistent throughout. So now let's look at some configuration for a dynamic RP in a PIM bidirectional environment, and it's really no different than it is in a PIM sparse mode environment. But let's quickly go through this. So we have a design criteria. Let's provide HA and load sharing of multicast groups under non-failure conditions. This time we've got 3 multicast groups selected, and we have two RPs, so we can load share. So I've got a 192.168.171/32 and a 192.168.1.172. All the priorities are the same. The only difference is the BSR. For the .171, we've got a priority of 10, so that will be selected as the BSR. So let's go across to the config, and so we've assigned the loopback of one of the RPs .171 on the switch on the left, and then the .172 is allocated to this switch on the right. So these are our two different loopback RPs on each of these two switches. Now there's no real difference for the candidate BSR and the candidate RP configuration, so we're pointing it to the loopback, and that's the local loopback here, 171, with a group prefix of including everything. Now we have selected the BSR candidate, but we've given that a priority of 10, so that will always be the BSR between the two. And then same configuration on the other core switch, selecting 172 as the RP. And so what will happen is when we look at our RP sets, we see that both of these are actually selected as the RP, and what multicast will do, because we've got all of the groups going to both of these RPs, that the groups will load share amongst the two RPs, so that gives us some load sharing under non-failure conditions when we're using default configuration effectively. And just quickly going over the other areas of where you would have PIM bidirectional configured. As before, on each hop we must have PIM bidirectional enabled, and then for the routing PIM process you just enable it. Everything else, as it's dynamic, doesn't need to be configured here. There's no static configuration. Similarly on this aggregation switch as well. Again, each hop we must have the PIM bidirectional on the layer 3 interfaces or the layer 3 elements, and then the router PIM is just enabled. Now we go across to a short demo which shows Phantom RP in a very small environment. Let's take a quick review of this setup for Phantom RP redundancy. You have various hosts and receivers in this setup. We have a physical host and receiver with a video stream, which we'll see later. And then we have various traffic pattern with multiple hosts and receivers on our traffic generator, so we can analyze the traffic. We have 3 Phantom RPs in this setup. The primary RP is on this aggregation switch with the longest match or the longest mask, and then we have a secondary and a tertiary RP on the VSX pair on the primary and secondary respectively. We'll make various failure scenarios and see how it affects our traffic patterns. And remember, the importance of the RP in PIM bidirectional is it is not only in the control plane, it's also in the data plane. So let's get to our demo. Let's take a quick look at our demo setup. So on the top left we have our multicast source, and we have a single receiver here on the bottom left, so we can visually see what's happening to our traffic, which is traversing from this access node here, from this host to this receiver here on this VSX pair. We also have multiple streams as detailed earlier. So the first thing we're going to do is we're going to simulate a failure on this aggregation and remove the primary rendezvous points for these streams and see what impact it has on the traffic, and we'll observe the stream and the traffic generator. So that's seems to have no impact on the traffic here. We can see we've had no packet loss as well by taking out the primary RP. So next what we're going to do is, in the same state, we're going to now boot the secondary RP, which is in the primary VSX node in our topology, and see what impact we have on the traffic, and see how the tertiary RP on the secondary VSX nodes takes over. Let's boot the primary VSX node. So what we see is some traffic loss and approximately a 430 millisecond packet loss duration or outage. In summary, we simulated removing the RP on the aggregation switch, which was the primary phantom RP, and we saw zero outage. We then booted the VSX primary, which had the secondary phantom RP, and that provided a small loss of 430 milliseconds. So depending on where you put your RPs in PIM bidirectional network, we showed that we could get 0 to small outage in this small setup. I hope that was useful and informative to you, and thank you for watching.